Welcome to Unit 1, Lesson 11. There was no Unit 1, Lesson 10, so don't freak out. You still here, you still with me. Now, what we're going to focus on for Lesson 11 is more doing quadratic problems, but in the form of word problems, okay? And this is the type of example, or these are the type of problems you might see on the short answer part of the exam, all right? So it's pretty critical to understand how to break down a word problem and actually how to solve it, especially if it's quadratic, especially if you have a calculator, because not every problem tells you to solve it algebraically. Some problems just say, find the solution or find the answer. If that's the case, we will definitely use the graphing calculator. Now, before we even get started, we have this table here, and it is for review. So I'm not going to go over every single nook and cranny here, but these are just reminders of processes or how we do things, okay, depending on what they ask us for. All right, if you need to review something that we specifically do in a calculator, go back to previous lessons and check those out. All right, so first off, let's take a look at our roots. Okay, use green. If they want us to find the roots, that's the same thing as the zeros, right? The x-intercepts, okay, the solutions. It's the same thing, roots, all right? If we want to find that out algebraically, the first thing we need to do is we need to set our quadratic equal to 0. That is the first thing anytime we solve something, okay? Any method, if it's a quadratic, we set it equal to 0, all right? And then we can solve by factoring, or if we can't factor it, we can use our quadratic formula. All right? So first thing, set that quadratic equal to 0. We can factor and solve, or we can use the quadratic formula. All right? How would I do this graphically? Well, right here, it's the x-intercepts. My x-intercepts, that's right where it touches the x-axis, my graph, okay? Now, you need to use our 0 function in the calculator. All right, and remember, make that bow tie, because you're going to have to set a left and right bound, and you want to make sure when you do that that the arrows point toward each other. All right, now we have a sample question here, and I'm going to solve this algebraically, and then I'll just show you quickly what it would look like on the graph. All right, so two numbers that multiply to 12 that add to 7. Oh, love it when it's easy. 4 and 3. Let's not forget we want to set that equal to 0. And now I T-bone this, which is basically solve it. X plus 4 equals 0, and x plus 3 equals 0. So my two answers should be x is negative 4 and x is negative 3. All right? Now, if I were to graph this, here's negative 3, here's negative 4 on the x-axis. If I were to graph this, my parabola would go through both negative 4 and negative 3, because those are the solutions. That's how you know they're the solutions. It goes through those 2 points, negative 4 and negative 3. All right. Let's go on to the next one, and let's take a look at the vertex. Now, at any time, if I'm going somewhat fast, just tell me to slow down. I'm kidding. This is a video. You can't tell me to slow down. You pause it, you back it up a little bit, and you play it again. Vertex. All right. First of all, the vertex is a coordinate. You need an x and a y. It is a coordinate. And we are going to solve for the x and y individually, one at a time. In order to find my x, I just take negative b and put it over to a. That is my x. Now, if I want to find the y value, okay, because all we did was find the x right now, my y value, I plug my x into my equation, and I just evaluate that. That's going to give me my y value. So now I have an x and a y, and guess what? X and a y, and I have my vertex. Algebraically, that's not too bad. But it's always nice when we can have the calculator find it for us. Okay? So keep in mind, when I graph something, it's either the low or it's the high point. Okay? It's either the low or the high point. That's because a parabola can open upward. Okay? Like on the first example I gave you, this parabola in red here, this is a low point right there. All right? If my parabola were to open down, then it would have a high point, wouldn't it? Okay? So, how do we do this on the graphing calculator? You want to use your min or your max functions. Okay? You want to use the min or max function. If it's a low point, you use the minimum function. If it's a high point, you use the maximum function. And let's not forget, when we do our boundaries to find the min and max, we got to make the bow tie in there. So, we have a problem here. And it's that we're doing math. No, but seriously. Y equals x squared plus 8x minus 2. All right? I'm going to solve this algebraically, then I'll draw you a picture of what the graph would look like, in general, in relation to the vertex. So, I want to find my x first. And you know what? I've been dying to do something here. Calligraphy pen. Let's use thinner and see if that works. X equals, it doesn't make that big of a difference, negative b over 2a. Okay, let's not forget my a is my 1, my b is my 8, and my c is my negative 2. That's where I'm getting my b and my a value. So I negate my b value, which is 8, all over 2 times my a value, which is 1. That's negative 8 over 2. That would be negative 4 equals x. This is the x value to my vertex. Now, how do I find the y value? I simply plug that in. Y equals x squared plus 8 times x. Get rid of the minus 2. Mr. Visca likes to put parentheses wherever I'm inputting my value. Okay, so negative 4, negative 4. 16 minus 32 minus 2, that's negative 18. And that's my y value. So if they're asking me for the vertex, negative 4, negative 18. That's my vertex right there. All right, negative 4, negative 18. So, and I'm going to go to the far left side here. If I were to draw this on a graph, negative 4 might be here. Negative 18 might be way down here on the y-axis, negative 18. My coordinate would be way down here, the vertex. And it would open something like that. All right? That's the low point. It is a minimum. I would use the min function for that. All right, all right, all right. This ain't too bad for review. This ain't too bad, people. So, what if they want us to find the x value and they give us a y value? Okay? So all I would do is I would plug in my y, okay, and then solve for my x. That's it. I would plug in my y, then solve for my x. Usually, I make my equation, I set it equal to 0, which means I would factor, yep, that's an r first, and then solve, or maybe use a quadratic formula. Okay? So, I plug my y into my equation, I just solve for x, usually setting it equal to 0. and I factor and solve, or use the quadratic formula. All right? So, what if I'm using a graphing calculator? All right, well, that's a good question. Okay, I plug my y into y1, whatever it is. Let's say y was 3. y1 in my calculator make equal to 3. I plug my equation, my other equation, which is usually quadratic, into y2. And then it's where they intersect. You need to use the intersection function. It's where they intersect. That's the answer. Okay? Let's do this. Let's do this. Oh, wow. Y equals x squared plus 4x plus 4, where y equals 1. Okay, this is what they give us right here. So all I'm going to do is plug a 1 in for my y. Equals x squared plus 4x plus 4. All right? I'm going to subtract 1 because I want to set my equation equal to 0. 0 equals x squared plus 4x plus 3. And I'm going to factor and solve that. Two numbers that multiply to 3 that add to 4. It's x plus 3, x plus 1 equals 0. If I t-bone this, I'm going to get x would equal negative 3 and x would equal negative 1. There you go. Those would be my two answers. Now, what would it look like if I was graphing this? Okay. If I was graphing this, here's negative 1, here's negative 3. My parabola would look something like, it would kind of go up like this. Would touch it once. Okay. And then, wasn't my y equal to 1? Sorry, I put that right there. Bam. My y was equal to 1, wasn't it? Here's where y is 1. All right. It would cross. I'm going to draw this in red. Here's y equals 1. It would cross. Oh, that's kind of bad. At negative 3, I'm going to put a big dot right here and a big dot right here. They would intersect each other at negative 3 and negative 1. These are the points of intersection. Okay? And that's why I get my answers, negative 3 and negative 1. Last but not least, before I let you guys loose on this, is what if I need to find a y value given an x value? This is the easiest of all. I just plug in my x value. I plug in my x value. All right? Now, what about if I use a calculator? I don't know. Put your equation into y1. Yeah, that's yi. Put your equation into y1, and then just look at your table. Just look at your table for your x value, and then you can find the y value. But really, I don't know anybody when they're just trying to solve for y if you're given an x value. I don't know anybody who looks at their table. It's much easier to plug it in, especially if you have a calculator. You just do the math. Meaning, x equals 2 here, right? So y equals x squared plus 3 times x minus 5. X is 2, so that's what I'm going to plug in. 4 plus 6 minus 5, and that equals 5. That's your y value. All right? Those are 4 kind of critical points that we reviewed, both how to do them algebraically and how to do them in the calculator. And now I think we should probably go ahead and do some of these problems, okay? One more thing before we get to the actual problems we're going to solve. Some of the notes that I hand out to the students have these and some don't. I edit them, and that's the same as with any of the lessons I do here. But sometimes kids, when they're looking at a calculator and they're looking at a graph, I don't see the min or max, or I don't see something on there because the window in the calculator does not fit the graph they put in here. If you hit the button zoom and then pick the choice fits, a lot of the times that will put the meat and potatoes of your graph into the window. And what do I mean here? Let me call this up. Let me go to zoom standard. If I hit zoom standard, that will automatically, that was choice 6, give me a 10 by 10 window. All right, but let's say I do this. Y equals minus, come on. Let's call it minus 8x minus 15. If I graph this bad boy, I don't see the min or max. It is way down here. So if I hit zoom, and I don't see fit here, but if I scroll down, there it is, choice 0, and hit enter, it will try and put this graph to a point where, look at, now I can see the minimum. See, it doesn't do everything great. I see a lot more of the left than I see the right, but what it tries to do for parabolas is include my min or max, my vertex, and my 2 zeros here and here. So that's how you can definitely start. After that, we can always adjust the window. Let's say I wanted to see more of the right side here, and I want to see a little bit lower on the graph. I go to my window, and the right side would be where my x's are positives, correct? Let's go to 20 instead of 10. All right? And now let's say I want to see lower on the graph. That means I would have to go farther down on the y-axis, which is here, the y minimum. Let's call that negative 50 instead of negative 30. Now when I graph that, I definitely see more of the right, and there's more space down here. Okay? So you can hit zoom fit, and then you want to make adjustments, and this is on the window button. Okay? You can always start right here. Okay, you don't have to go to zoom fit. I mean, that's not like the best thing in the world, but that's a little hint to help you get started and give you a place to make adjustments, I think, easier if you hit zoom and fit. All right, I'm not going to have you do this. What would be an appropriate window for this graph? That's fine. If you want to practice it, that's fine. Same thing here. This is where we're going to start. All right, this is where we're going to start. A baseball player throws a ball from the outfield toward home's plate. Okay? The ball's height above the ground is modeled by the equation y equals negative 16x squared plus 48x plus 6, where y represents the height in feet and x represents time in seconds. The ball is initially thrown from a height of 6 feet. If necessary, round your answers to the nearest hundredth. A, what is the maximum height in feet that the ball reaches? Okay, maximum. Right now, I know this is a parabola. My maximum tells me vertex because it's either a min or max point. So I'm going to graph this, and I am going to find the maximum height in feet. Now, it tells me round to the nearest hundredth if possible. That is 2 decimal places. All right, that is 2 decimal places. So what I'm going to do is I'm going to take my calculator and I'm going to put in this equation. All right, I'm going to put negative 16x squared plus 48x plus 6. And I am going to go zoom and go to my standard window, which is my standard 10 by 10. And yeah, I don't see, it looked like it went up and went way off here. So I'm going to go immediately to zoom fit. Okay, I know that's 0, but I'm going to still scroll down so you see it. And hit enter. And here we go up. Okay, so I see my max here, and I see a couple zeros here, and that's nice. But I want to see higher. I want the max to be, right around here because I'm picky. I like to have more space. So I'm going to my window, and I'm going to make this go higher. I mean, look at that. It goes to negative 2,000 on the low point and only 41 on the high point. Let's call that 100 by 10s. Okay, let's graph this. Let's see what happens. Oh my God, it's still barely there. Let's change my window one more time. And I don't need to go this far down. That's insanity. Let's see if that looks nicer for us. Oh, that's so much nicer. Okay. Now I know my maximum is the vertex right here. So how did we say we need to find the maximum point using the calculator? I believe we said we use the max function. Okay, we're going to use the max function. So let's quickly do that. All right, I'm going to go to the calc menu because I want the calculator to calculate the maximum. Second, trace. And I pick number 4, which is my maximum. Now I've got to make the bow tie. I hit enter to the left. Boom, puts a little arrow. Now it's telling me the right side. And I hit enter. Bow tie. It wants me to guess. Sure enough. So my maximum would be 1.5 comma 42. That is the x and the y value. This is, my x is in seconds. At 1.5 seconds, it is 42 feet. There you go. And we're going to stop there because I have to teach.